Welcome to Hyperfixation Investigations, the podcast where two neurospicy best friends take time each Saturday to info dump their research deep dive of the week.
Lovingly produced and copyrighted by Wolf and Stag Productions.
Today's fun fact is, today over 160,000 acres of redwood forest are protected by federal, state, county, and local parks on the Redwood Coast.
Good morning, I'm Josh, and I'll be presenting this week's episode, Megaflora. We like big trees and we cannot lie. Part 2 of our miniseries, The Deep, Dark, and Dirty Depths.
Good evening, I'm Kara, and I'm just along for the ride. For those of you joining us for the first time, how things work here is that Josh will be leading us through a mini lecture on the topic in the first half, so that we can discuss the topic later in depth in the second half.
Expect tangents throughout. We switch off duties each week, so next week expect Kara to helm the episode.
Now to our regularly scheduled program. Josh, what have you been hyperfixating on this week?
Well, Kara, I've been deep diving recently into a couple of my favorite megaflora.
Okay.
So, first of all, when I use the term megaflora, this is just a term typically used to describe extremely large species of plants, right? So mega, large, flora, plant. Megaflora, large plant. Yeah. Usually these refer to the species as a whole, particular species of plants that are extremely large. Some examples are the California redwood, the African baobab tree, the corpse flower from Indonesia.
Oh, interesting.
And the mountain ash, which is also known as swamp gum in Australia. And eventually, I'd love to talk about all of these. But today, I'm going to start by talking about the coastal redwood tree.
Okay.
And then eventually, I'm going to get into one of my favorite megaflora, Pando.
Pando?
Yes,
Alrighty.
yes. An individual tree, but we'll get to him.
Okay.
Yes. So, first of all, coastal redwoods.
Okay.
Are what I'm talking about today.
I'm guessing that means there's more than one type of redwood.
Yes.
We won't get into that, but that's just...
No, there's a variety of redwoods, but the Sequoia sempervirens, scientific name for the coastal redwood, they can live 1,200 to 2,200 years.
Wow, so a couple millennia in there.
Yeah. Redwoods commonly grow more than 300 feet tall, with the tallest known tree in the world being a redwood that was measured in 2019 to be 380 feet tall.
Whoa.
And these trees can reach up to 29 feet wide, or 8.9 meters.
Wow. Okay, wait. So 380 feet. That's like 38 stories of a building. And if I'm not mistaken, because I have random knowledge about things like this, isn't the Statue of Liberty like 300 feet tall?
Oh.
So this redwood is taller than the Statue of Liberty by like a whole ass building.
Yes.
Wow.
Yes. But yeah, most redwoods are on par with that height.
Statue of Liberty. 305.
305.
Live fact check.
Live fact checking. Despite being this tall and this wide, redwoods are one of the tree species that have virtually no taproot.
Oh, interesting.
Right. We discussed this a little bit in my last roots episode.
Right.
That a lot of trees actually don't have taproots, or if they do, they outgrow them after their sapling stage. And redwoods are one of these. They do not anchor themselves very deeply in the earth either. Their roots typically only go as deep as about 10 to 13 feet.
Wow.
Or 3 to 4 meters. And most of their roots grow laterally sideways, right? Off 60 to 80 feet from the base of the tree.
Wow.
So they use just growing sideways to stabilize themselves far more than growing down.
So wait, like 13 feet. The depth of their roots is 13 feet. The trees themselves are like 300 feet high.
Right.
So by ratio, it's like, what, 4% of the height of the tree is equal to the depth of their roots? That's crazy. That seems like a very, very, very small amount of depth compared to height.
Right. And yet again, they live thousands of years.
Right, so clearly it's working for them.
Right. Hey, it works out. Coastal redwood conifers grow natively in a fairly small region in the American West along the Pacific coast, where there is plenty of fog to keep them moist. And in fact, fog is a huge source of their water. Partly because, yes, the fog condenses on their needles and eventually falls to the forest floor, creating kind of a manufactured rain, tree-ufactured rain, if you will.
Mm-hmm. Thank you for that pun. We appreciate it so much.
You're welcome. Which this does also provide additional water to the ground cover and smaller trees of the forest floor. But the fog also provides them with water directly because redwoods are actually capable of absorbing water directly from the fog through their needles.
Huh. Is that unusual for trees?
Yes.
Okay.
Yes, they have additional special pores in their needles that allows them to just kind of suck in that moisture directly.
Very nice.
Yes. Now, part of the reason that redwoods are able to survive as long as they do is in part due to the incredibly high concentrations of tannins in their wood, which you may have heard that this is what protects them from most bacteria and even fungi, and is what gives them their signature red coloration.
Okay, now, tannins, when I think of them, I think of red wine.
Yes.
Okay.
Yes. Same class of chemical compounds. They're a grouping of bitter and astringent chemical compounds that occur naturally in a ton of plants.
Oh.
They happen to occur in very high concentrations and quantities in redwoods.
Cool. I like that the redwoods are bitter. I feel like that just, it fits my vibe. I love redwoods. I'm a bitter person. Redwoods are bitter trees. It just works.
No, it does. It does. Tannins are a natural pesticide. As I mentioned, they're great at protecting them from bacteria, even fungi. So this makes the tree's wood too bitter for most insects to also want to eat them.
Vibe.
So the insides of redwoods are rarely damaged by insects or fungi or bacteria for the most part. Redwoods are also fire resistant because of these tannins.
Huh.
Tannins generally are a natural fire retardant. They are a chemical class that is very difficult to burn.
Okay.
And in addition, the older trees have bark up to a foot thick to protect the inner wood from catching fire.
Very nice.
And this bark is then typically highly saturated with water and has almost no pitch or resin, which in most pine trees is very common.
Right, like the sap kind of, right.
Right. And that pitch is highly flammable.
Huh.
So redwoods being one of the conifers that has fairly low concentrations of pitch on their bark makes them less flammable than most pine trees. Add in the high quantities of tannins and the fact that their bark is so thick.
Right. That's cool. I think too, I don't know about anybody else, but when I think of pictures of the redwoods, you're used to just seeing the super tall bases, trunks and stuff. Like they're so tall that you don't even really see the foliage aspect, the leaves or the needles or anything. To the point where I feel slightly stupid saying this, but I don't think I realized they were conifers.
Mm-hmm. Yeah, no, that's
because when do you see pictures of the tops of redwoods, at least in a way that they're like, oh, these are the iconic redwoods, because we're so used to seeing the red bark of the really tall trunks.
We're so used to just seeing like a ring of like 20 people standing hand to hand around the tree trunk in a ring. Just, oh my gosh, there's that many people. They look so tiny next to this huge tree. Yeah, no, that's fair, honestly. However, redwoods are not immune to any of these things that I've mentioned.
Insects, fire, all that.
Yes. Okay. They have great resistance for sure, but not immunity, because you're never going to get true immunity from any of these things. The tannins and other elements of their physiology just make them very hardy and more resistant than many of their cousins. So as any tree gets older and wider, the center of the trunk dies out, as it's no longer really included in the vascular processes of the tree.
Okay.
Because those occur closer towards the outer body of the tree, and close to the inner bark. This core of non-living wood at the center of a tree is then known as heartwood. I'm not saying hardwood, but heartwood, as in like thumpa-thumpa, your heart.
Right.
This is generally the central pillar around which the rest of a tree builds its future stability. Because as a tree gets older, it grows wider and adds layers to its heartwood center. This is where we see those rings.
Right, the age rings,
Because it's not just, it adds a little bit more to the outside and a little bit more, but it adds more and more to the center of the tree.
Right.
And I say non-living in terms of it's not actively being nurtured or fed.
With the vascular system of the tree.
Right.
Right. I feel like you see heartwood furniture.
Yes.
By some craftspeople.
Yes.
Is it harder?
Yes.
Okay.
Yes. So because
it has all that pressure on it too, right?
Yes. The heartwood is the densest and hardest wood of any given tree because it has packed itself in, basically, as it grows outward.
Okay, that makes sense.
The reason I'm mentioning it, though, is because, ironically, the heartwood is one of the places in which the coastal redwood is particularly vulnerable. Because if fires or falling limbs or other falling nearby trees happen to damage the incredibly thick bark of a redwood, that damaged area can eventually die, decay, and expose the heartwood.
And the heartwood doesn't have anything in it to protect it because it's quote-unquote non-living now.
The heartwood, I mean, granted, there is often plenty of water and other nutrients latently in the heartwood.
Sure.
But that heartwood can then be more easily damaged by future fires and becomes a target for some fungi. Now, there are only a few fungi that can target redwoods, but they will slowly eat away at the heartwood. And other fungi and fires can then hollow out these trees.
And that would, destroy its stability, right?
Far less stable at the very least. But even with that structural damage, the living wood near the perimeter of the tree is still well protected from these fires and fungi due to their wetness and their tannins. So even with these huge hollow cavities, redwoods can still remain standing for centuries with these huge hollow openings. When they occur, especially near the base of the tree, they're called goose pens.
That's funny. Is that what they used to be used for? Or is it just a funny name? Did people keep their livestock in there?
You know what? That would be a good question to double check on. I'm not sure. I think it's just a funny name.
We'll talk about it in the discussion.
I'll look it up for the discussion portion. Yeah. But so long as they have enough living wood to transport nutrients throughout the tree, elsewhere, the hollowed out area of wood isn't too big an issue.
Right.
But it should not be surprising that the most common natural cause of death for a redwood tree is being knocked over by a particularly strong gust of wind.
Yeah.
Yeah. Especially when there's a large goose pen near the base of a tree. And this is known as wind throw, right? The wind throws the tree around.
Yeah.
And the effects of strong winds are often fairly well mitigated by having enough surrounding trees acting as an effective windbreak. But even in the heart of a redwood forest, some of the older trees, on less steady ground or with large goose pens, will still be susceptible despite a decent windbreak just because of their size.
Sure. The bigger they are, the harder they fall.
Right.
Yep.
It's easy for the wind to affect something that has a lot of surface area to smack against.
And that is essentially top heavy. I mean, as much as the roots go really wide for stability, because they don't go deep, when you do have something battering against the very, very large top portion, it is still going to end up being top heavy.
Right. Which, granted, the lateral growing roots do a pretty darn good job.
Oh, for sure.
Again, thousands of years of age.
Yeah.
For most of these trees. But speaking of these lateral root systems, because they don't go very deep, they do actually offer an additional benefit in terms of how many options there are as far as reproduction is concerned. While most trees generally reproduce by dropping fertilized seeds during springtime,
right,
and then sprouting from those seeds during the following year, some trees, like the redwood, do have a habit of actually forming a new sprout from pre-existing roots.
Oh.
Right? They actually grow like a secondary trunk from the same root system and may even grow several trunks.
It's like Groot.
Yes. So they can eventually look like an entire small grove of trees that are actually just one tree because they share the same root system.
Right.
And are from the same parent tree.
Right.
And there are many trees that do this on occasion, but redwood trees do this quite often. So much so that it's not uncommon for people to find a nearly perfect circle of redwood trees that all grew from the same original tree and share that single root system. And if the original tree has died, the circle of trees looks like a perfect circle and is then often called a fairy circle.
Yes.
Yep. Because they look like, oh, this strange growth of trees magically growing in this beautiful little circle.
Yep. Please do be careful what you do inside of those if you ever go visit one.
Right. If you put any stock in anything supernatural, paranormal
at all,
be careful.
Please be careful.
Be careful. Like even I don't want to tempt that shit for the most part. But yes, these members of this fairy circle are one organism that just happened to grow about the same distance from their original trunk.
Mm-hmm.
Probably because that's the closest to the original trunk they could be to still have strong supporting root systems and be just far enough out so as to not get shaded out by their parent tree.
Oh, sure.
And actually receive enough sunlight to keep growing. And this is actually the redwood tree's preferred method of reproduction.
Huh.
Because their seeds rarely germinate. Coastal redwoods produce seeds in huge quantities.
Mm-hmm.
Huge. Again, massive trees. And they have somewhere between 50 to 60 seeds per pine cone, according to the National Park Service.
Mm-hmm.
I've seen claims varying how many cones they're capable of producing in a year.
Oh, sure.
But I've seen claims up to thousands of cones in a year. So thousands of pine cones with 50 to 60 seeds per pine cone.
That's a lot.
Right. But remarkably few of those seeds actually gain a footing and sprout.
Is it just like they're picked up from the wind and blown, or they can't actually root properly in the soil? Is there, like, do we know why?
Depending on, and again, I've seen varying numbers on this.
Yeah.
So it's hard for me to determine necessarily which one is the number.
Sure.
But it seems that anywhere between 1 to 15% of seeds are even viable.
Oh.
So even if they do get in decent soil, many of them simply won't sprout. But it seems like the 1 to 15% viability does depend somewhat on the age of the tree.
Mm-hmm.
And again, soil quality and local nutrient availability is definitely a factor.
Yeah.
So it's difficult to pin down an exact cause and figure for this.
Sure.
But yeah, their seeds generally just don't germinate very well. Most of them aren't viable, but they do drop thousands every year. But regardless, most of the time they will just sprout and reproduce off of their own root system. Now, I'll also clarify that some of these sprouts come from the stumps of dead trees, right? And many will grow out of the side of a fallen redwood. So a fallen tree trunk might look like it's still got some really strong branches growing on it, but it could in fact just be a row of new trunks growing out of the old, now effectively dead tree.
Huh.
So you get a line of redwoods or sometimes a little circle of redwoods growing out of the edges of the bark of the dead tree.
Sure.
And so fairy circles and the sprouts growing out of the trunk are sometimes also called family circles.
That makes sense.
And are common when the sprouts emerge from the circumference or outer edge of the original trunk, which then makes that particular circle very tight-knit.
Right.
Especially as the trees grow up and they end up growing into each other on the sides. So that's a pretty common sight in redwood forests as well, which is yet another reason that goose pens are pretty common.
Right.
Because if one sibling tree gets knocked over, it's going to pull the side off of its
other tree. Right.
Right. Now, in each of these cases I've mentioned so far, most of these sprouts do eventually develop their own root systems over time, and they separate for one reason or another. Sections of roots will die out, or some of these clonal root systems will self-prune, and when the roots end up too far away from the current trunk of the tree will stop wasting energy, right, trying to support those distant roots.
Sure.
Or sometimes previously connected root systems will be torn up by a tree falling over in wind throw, separating these clones.
Yeah.
And in the case of trees other than redwoods that behave this way, there are, of course, many other ways for a single trunk to be killed and its nearby roots, therefore separated from its siblings.
Yeah.
And whenever a plant self-propagates in this manner, it is considered to be cloning itself because it's creating new stems without any new genetic information.
Right. It's not sexual reproduction.
Right.
Yeah.
Right. It's just each trunk in a clonal tree are genetically the same, It's just growing new trunks, new sprouts from the same body. And that brings me to the original reason I wanted to do this episode. And the original reason that I ended up doing any research that became last week's episode, or sorry, not last week, but 2 weeks ago, my last episode on root structure and all that, which is a tree named Pando.
We love Pando in this house.
Yes. Pando. So Pando is kind of a technicality in an episode about Megaflora.
Okay.
Because usually Megaflora refer to a species has a tendency to grow very large. But it's a technicality I'm willing to argue. Because Pando is generally considered to be the largest living tree.
Okay.
So Pando is a male quaking aspen tree. Scientific name, Populus tremuloides, sometimes also known as golden aspen, mountain aspen, white poplar, trembling poplar, or popple.
Oh, that's so cute.
Right. Quaking aspens in general are considered to be a fairly tall and fast-growing tree native to the cooler regions of North America.
Okay.
They typically grow about 50 to 60 feet tall, 15 to 18 meters, and are an average of 10 inches or 25 centimeters in diameter near the base.
So more like a normal tree and tall and skinny kind of?
Yeah.
Sure.
Yeah. They're not that hefty looking usually.
Mm-hmm.
Though the record for these, as far as I could find, was actually up to 119 feet in height and 4 feet 6 inches in diameter.
Wow.
Yes. Quaking aspens are known for their smooth, whitish bark with horizontal black markings, which are usually scars of some kind, and have leaves that are typically round, though may resemble spades from playing cards, and often have small, rounded teeth or vaguely soft, serrated look to them.
Yeah.
Their leaves usually turn yellow in autumn, though have occasionally been documented turning orange and red, depending on genetics and soil nutrients.
Sure. So very pretty.
Yes.
Yes.
Yes. And when I say Pando is a male quaking aspen tree, I do specifically mean that researchers Michael Grant, Jeffrey Mitten, and Jan Linhart from the University of Colorado at Boulder examined Pando in 1992 and studied its pollen production, leaves, and root structure to determine its sex.
Okay.
Because trees do have various sexes for reproductive purposes, right?
Yeah.
And they are actually also the ones who coined the name Pando, but we'll get into that more later.
Okay.
Now, the way that one of these trees, not anywhere near as large as the redwoods we were talking about earlier, could possibly be considered the largest tree in the world is the reason for this episode in the first place.
Right.
Cloning.
Yep.
As I mentioned with redwoods, cloning is a preferred method of reproduction for quaking aspens.
Okay.
They primarily propagate by means of cloning. They grow sprouts upward as new stems from their pre-existing root systems. And part of the reason they don't often grow from seed is limitations in pollinating.
Okay.
Because quaking aspen trees are either male or female, but you need to be able to properly cross-pollinate in order for the seeds to be viable, right?
So if there's not enough variety of males and females in a close enough geographic area, the seeds just don't have a chance.
Right, the seeds
of doing sexual reproduction.
Yeah, they just won't be viable.
Cool.
Because they'll grow in a little grouping, all in the same sex.
Yeah.
So you'll have a grouping of male trees, and then a little ways away, a grouping of female trees. If they don't happen to get cross-pollinated properly, then their seeds will not be viable.
Okay.
And even if they do get proper pollination, their seeds don't have any stored source of energy to last additional seasons or any protective coating to deter from being eaten.
Right. Yeah.
So even if they are viable...
Squirrels and birds.
Right. So even if they're viable seeds, they probably get eaten.
Yeah.
Or they might decay if they don't end up in a ideal situation to grow. Because some seeds, for other plants, some seeds can last years and still be viable.
Right.
Quaking aspen,
not so much.
That's kind of a rarer case for them.
So, cloning.
Right. Pando's built different. He's not like other girls, all right? This particular quaking aspen has cloned itself so many, countless times, it has effectively taken over a small portion of Fish Lake National Forest in central Utah.
Wow.
According to the U.S. Forest Service, Pando A single self-cloning tree has spread over 106 acres of this forest.
Wow.
And is estimated to consist of approximately 47,000 trunks or stems.
So it kind of looks like its own forest, but it's all one tree.
Right.
Wow.
Right. That's part of why I love Pando.
Yeah.
He is an entire forest in one tree. 106 acres is 43 hectares.
Okay.
Which makes Pando the largest living tree by land mass.
Okay.
And on top of that, Pando is estimated to weigh in at nearly 13 million pounds.
Jeez.
Or 6 million kilograms, which means he is also the world's heaviest tree.
Interesting.
So Pando is the largest tree by landmass and weight.
And do we know why Pando has self-propagated so many times?
As far as I'm aware, it's mostly a situation of the conditions just being right.
Okay.
For Pando
so it's not
for so
like
long.
Some weird cancerous genetic mutation thing?
Not that I found in my research, right? It seems like Pando just is well suited generally to this climate. This area of central Utah is just kind of an ideal spot for it to have happened to grow. I will say, though, when talking about what counts as the largest tree, there are many different ways to categorize what trees are the largest and in what ways. So I just want to be very specific in stating that Pando is the largest living organism by weight and landmass.
Okay.
Now, there are other trees of different species that are larger in other ways.
Right,
so,
like that giant redwood that is the tallest tree.
Yes. There is a giant sequoia specifically, which is in the same family as redwoods.
Okay.
Whose name is General Sherman.
I love that.
Right. Which is the largest single stem or unitary tree. But Pando is the largest clonal organism as well. So for reference, Fish Lake National Forest is approximately 1.5 million acres, which are managed by the U.S. Department of Agriculture Forest Service and is named for Fish Lake, weirdly enough.
Strange.
Right. Which is, by the way, the largest freshwater mountain lake in Utah.
Huh. So Fish Lake National Forest just has a bunch of nice, large things going on.
Yeah. Yeah. Honestly, seems like a nice hiking spot in my mind.
If you've been, send us pictures.
Oh, yes. Pando is Latin for eye spread.
That's fitting.
Yes, and was given its name by the researchers I mentioned earlier, who examined Pando in 1992, and the name first appeared, as far as I could find it at least, in an editorial called The Trembling Giant, published in Discover magazine in early October of 1993.
All of that is just like an aesthetic that I appreciate.
Right. However, the first known identification of this tree as a singular organism appeared in an article written by Jerry A. Kemperman and Burton V. Barnes, which was titled Clone Size in American Aspens.
Not quite as fun of a title.
No. But Clone Size in American Aspens appeared in the 1976 publication of the Canadian Journal of Botany. And the article was documenting a study of multiple sets of aspen clones throughout central and eastern North America. The long and short of it is that they engaged in aerial photography, along with on-the-ground study of leaf, bark, and stem characteristics to determine whether or not these large groups of aspens were, in fact, clones.
Okay.
So in broad strokes, the article generally reported finding larger clones in and around the central and southern Rocky Mountain region, with smaller aspen clones in areas further east. And they attributed this larger size of western clones to the area having more periodic fires, less opportunity for seedlings to establish, which would then encourage reproduction via cloning.
Right.
As well as little competition with coniferous trees and even other clones.
Okay. Yeah, there's a lot of space in the Rocky Mountains.
Yeah. And this study took years. I believe it started in the late 50s.
Oh, wow.
Right. And then was published again in 1976. So about a quarter century for one study on quaking aspen clones.
And I think maybe earlier than most people would think that we were looking at cloning in anything.
Right.
Yeah.
Fish Lake National Forest itself has been studying Pando and working to preserve and protect him since at least 1987.
That's good.
Yes. When it comes to determining Pando's age, things do get a bit tricky.
Okay.
Because most quaking aspens live 80 to 100 years.
Yeah.
Though some of the stems in Pando have been documented at approximately 130 years old.
Mm-hmm.
That being said, the root system is much older than that.
Oh, yeah, because it would kind of be like the center older trees would die out.
Mm-hmm.
The new clones would kind of take over, but that root system has been consistent.
Right.
Yeah.
But with new stems growing to take the space of the older trees.
Right.
Hence how it's managed to spread out. Now, I have seen online some truly wild claims about Pando's age that should not be taken seriously.
Yep.
That claim that he's as old as 80,000 years. I want to be very clear that, as far as I can find, scientists who have interacted with Pando consider that to be an absurd estimation.
Hasn't the continent moved since 80,000 years ago?
Not much.
Not much?
Not much. However, there has been an ice age since then.
Ah, that's the thing. Yep.
Yes. So learning the age of the organism from just tree rings, not an option.
Right.
Since that'll only tell us the age of that individual stem.
Sure.
Right?
That clone, right.
And the root system itself is constantly being replaced and is regrowing as sections of it die out or are damaged. So you can't really get an easy and clear, simple answer from that alone either. So some of the best methods we currently have still leave us with a range of possible ages rather than a definitive number.
Yeah.
Pando is believed to be many thousands of years old, which would help account for its size.
Sure.
Right? Because it can't have grown that much in just a few hundred years, maybe even a couple thousand. It's got to have been here for several thousand years.
Yeah.
But as I mentioned earlier, that ice age is agreed to be the limiting factor for maximum age for Pando. So there's evidence of glaciers in the region, including the exact location that is now home to Pando, until around 14,000 years ago. So for Pando to be older than that would require him to have survived being underneath a glacier, which is unlikely, given that glaciers scour out the earth as they move.
That glacier probably created the freshwater mountain lake that is Fish Lake, so...
Exactly.
Right.
Additional genetic studies of Pando have revealed fewer known genetic mutations than one would expect from anything more than several thousand years old. So additionally, trying to think of Pando as older than that ice age is, genetically speaking, unlikely.
Okay.
Between those genetic studies and the most recent ice age, estimates on Pando's age, at least estimates that are taken seriously,
yeah,
range anywhere from between 8,000 to 14,000 years. Even the low end of that scale, 8,000, that's an insanely long time, in my mind, for one single organism to exist.
Right, for one root system, essentially.
Right.
Yeah.
Constantly sending out new roots, growing new shoots, and regrowing as various shoots and roots die out. Now, sadly, there does appear to be some indications that Pando may be in decline.
Oh, no.
There was a study published in 2018 in the online journal, the Public Library of Science, that used a series of aerial photos spanning the decades from 1939 to 2011.
Wow.
As well as referencing the genetic work I've already mentioned to determine changes in Pando's boundaries over the years, and demonstrated a decrease in regrowth speed over the last 30 to 40 years.
I wonder what that lines up with.
Yeah. Which is to say that the new shoots are not sprouting fast enough to adequately replace the shoots that die off.
Right.
So, yes, this is likely, at least in part, due to human activity and disturbances in the area.
Climate change.
Right.
Yeah.
But the study was focused in particular on the effects of grazing deer and cattle because they eat the new growth before it gets a chance to establish itself.
Sure.
They were looking at specifically ways in which they could
mitigate the problem
and attempt to encourage Pando to regrow faster and maintain itself better.
So that's good at least, though, because it's not like there's some disease that has stricken it and is making it die. It's more like it's just the ratio of growth to decline is different than it was before.
Right. And it would not at all be surprising to think that this has happened to Pando before. Right.
Especially something that old. Cycles are like commonplace in very old things.
Right.
Yeah.
So it's not necessarily a death knell for Pando that it's in a period of decline for now, but it is certainly a point of concern.
Yeah.
And yet another indication of our influence on the local environment.
Mm-hmm.
Researchers spent a year from June of 2016 to June of 2017 collecting data from 3 areas within Pando, where they looked at a region that was simply left alone as their baseline and compared it to 2 regions of Pando that were fenced in. One of these fenced-in sections was only fenced off, and the other fenced-in section had 3 treatments conducted by the U.S. Forest Service, which included burning, shrub removal, and selective tree cutting.
Okay. Which can actually help the growth of trees.
Right.
Yeah.
Right. Being selective in it to make sure that they're not wasting energy somewhere that would be detrimental. Now, I didn't see when these treatments were in effect and how long they actually took place.
Okay.
I couldn't find that information clearly stated anywhere. But the researchers did note that those treatments were not ongoing when they did their own study.
Okay.
That being said, they noted that both fenced-in areas seemed to do similarly well, and thus they attributed this to a lack of accessibility to grazing animals that would eat the new sprouts.
That makes sense.
I want to also point out that the fencing was not put up exclusively for this study.
Oh, it was already in existence, put in place beforehand.
Yes, it was something that incidentally was present, and so they could look at and watch.
Sure.
Right? And while about half of Pando is protected by fencing at this point, fencing typically has its own set of issues and limitations because any fencing will be at least somewhat destructive to existing root systems and can be accentuated depending on how it's implemented.
Right.
Right? Are they using machinery or just simple manpower? Not to mention, fencing has to be properly maintained.
Right.
And the more foot traffic there is in the area, let alone machinery traffic, that can be detrimental to the plant. But if these researchers are correct in their assessment, then it would at least likely be a step in corrective direction, as fences would help to reduce the grazing of large animals.
Yeah.
But again, it's not the end-all be-all. It is a very interesting study. One in this series of, hey, what can we do to help protect Pando?
Yeah.
That recent study is also not necessarily ringing the bells of death for Pando.
Right.
It's just pointing out ways in which we could potentially focus our conservation efforts. And there are multiple active studies currently regarding Pando being done by both the U.S. Forest Service and a variety of independent researchers. And actually, the last main thing that I want to touch on before finishing up this section and moving on to our break is actually one of those independent organizations called Friends of Pando.
We love it.
Yes. Hey, great name choice.
Yes.
Mostly, I just find Friends of Pando to be an interesting and amusing organization because their primary endeavor is to 3D map Pando.
Oh, like including the root system?
Not the root system, but
just the clone,
above
the stems.
ground.
Yeah, okay.
Yeah. Part of the stated reasoning for this is to attempt to more accurately gauge the rate of regrowth over time that Pando is experiencing. And they apparently want to compare 3D photographic documentation to traditional photography in forest studies.
Okay.
They essentially went about this by sending teams of 2 into Pando along a series of predetermined routes with highly sensitive GPS equipment and 360-degree cameras to take a bunch, and I mean a bunch,
Sure.
of 360-degree photos every 7 meters.
So what? That's about 20 feet?
Yes, about 23 feet.
Yeah, okay.
Yes.
Be specific. I lived in Canada, folks. I've got a good...
Yeah.
Yeah.
And they created then a 7-meter grid of 360-degree photos to produce a 3D map of Pando. And as far as I can tell, they started this process in 2019 and started publishing their results and photographic data in March of 2023.
Sure.
So just last year.
Yeah.
And you can actually go to their website currently and explore these images of Pando, which honestly, I think is just really fun to look at around this 106-acre ancient tree. They have it labeled by section, so you can take some tours of the area. And I just enjoy that, there's just this random independent organization that, like me, enjoys this tree.
Yeah.
And is going, hey, how about we just 3D map this tree?
I love that.
Yeah.
That's really cool.
So you can take little photo tours throughout Pando and just see how massive this area is.
Right.
I think that's really all I've got currently on Pando, and Redwoods.
Alrighty.
So I think let's go to the break.
Let's do it.
Now that we finished our initial walk through the forest, we're going to take a quick water break.
If you'd like to join our email list, visit our website, www.hyperfixation-investigations.com, and fill out the subscribe form on our Contact Us page.
Please rate and review the podcast on Spotify and Apple Podcasts, and comment wherever you listen to let us know how you're liking the show so far. If you're enjoying listening as much as we enjoy talking, please tell your friends about us to help spread the show by word of mouth. The more of you there are listening, the better we can keep yapping about all the things we love. Alrighty, folks. Now that we've got our water refilled, let's get back to the hike. And welcome back. Done a little extra digging. Before we get into your main questions, one thing I wanted to address that we discussed in the first half was goose pens.
Yeah.
So I tried to do some additional digging. Unfortunately, in the time that we've had our little water break here,
it's been a bit longer than a little water break on the real side of it, but yeah.
Sure. But even so, I couldn't find a good, reliable source necessarily on where the term goose pen for these hollows in large trees originate.
Sure.
It does look to be that a lot of early American settlers did use redwood goose pens as places to keep their poultry.
Okay.
But again, that looks to be maybe something that's just kind of said about this, and I can't tell for sure how reliable that information is because I weirdly didn't see many people talking about it. Granted, it's a very niche question.
Sure, but still, you would expect like anthropologists or historians would at least mention it enough that it could be confirmed with a fact check.
Right, and I'm sure if I had more time to dedicate to digging, I could probably find something. But in the brief, hour we've had, I couldn't find anything substantive anyway.
Sure.
But it does at least look like you may have been correct in that's at least a reasonable assumption.
That actually kind of leads into something else that, I had thought we would talk about briefly, which is just like the idea of tree hollows in general. Mm-hmm. We know that they are home to creatures. Whether they're at the base of the tree or up a tree, whether it's a redwood or the oak in your backyard. I think it's an interesting kind of consistent aspect of trees that have heartwoods, especially where you see owls and squirrels and raccoons and all kinds of creatures hanging out inside these things because they are shelter and they are safe shelter for the most part.
Right. So at the very least, it would logically track that these were used as actual goose pens and other poultry pens. But yeah, unfortunately, I couldn't find anything to necessarily confirm that I want to actually cite. Because, when I find something and I go, oh, this is some random page in the middle of
a blog.
Right.
There's no sources cited.
A blog or a Pinterest post.
Right.
Or some random HTML page that has no additional identifying marker to it. Yeah, I don't really trust that.
Sure. I do think the other thing with the tree hollows are these tree hollows, especially the ones in redwoods that are like closer to the base of the tree or whatever. Mm-hmm. Is this how or where we see like the fires coming through the middle of trees? Because it's like hollow, right? Like the center of the tree is hollow and then it's burning from the inside out. And you're like, I know that's started usually by like lightning strikes or whatever.
Right.
But I think I hadn't realized that hollowing out of these big old trees happened as often as it does or as regularly as a part of the cycle of the life of a tree.
Sure.
Often. And therefore, like, there's the higher possibility of these cool internal burning trees happening, and we just don't see them as often.
No, it's amazing what trees can survive and what they can endure.
Yeah.
So unless you had anything else to say about goose pens,
nope.
That's really all I had on them at the moment was, yeah, maybe. Looks neat.
Yeah.
I don't know.
Seems logical.
But again, couldn't find any verifiable sources that I'm comfortable citing.
Yeah.
So, moving on then. Uh-huh. What other big questions or things from the first half did you want to revisit or investigate further?
Yeah, so this idea of obviously a lot of this episode is about cloning, self-propagation, sprouting, how these trees are creating new life. Is this idea of like the sprouting or cloning, is it only with conifers, or like, I guess my real question is, we obviously see that fruit trees germinate with sexual reproduction. They have to. That's how fruit is a thing. Are we somewhat biased in thinking about trees using sexual reproduction because of like how much we're told about fruit trees and whatever in our education system, compared to there's a lot of other kinds of trees out there that obviously don't do that use this sprouting or the cloning?
So the weird thing is there are lots of plants and trees of various kinds that do both cloning and or reproduction sexually.
Yeah.
And there are actually plenty of fruits, not just fruit trees, but fruits that can or do reproduce asexually via cloning. Strawberries actually can reproduce asexually.
Interesting.
And just clone themselves. That is sometimes sought out as a trait by farmers.
That makes sense.
Right? And in fact, in the last hour that we've had here, I kind of had a mini deep dive on just what plants can and do clone themselves or rely on cloning more or less than others.
Yeah.
And often when we think of trees, and I discussed this a little bit in the last Roots episode, trees are an example of convergent evolution. There are a lot of different organisms that we think of as trees, some of which are actually grasses like bamboo and palm trees. They're woody, so we think of them as trees. There are a lot of seed plants that also reproduce via cloning. Seed plants being a clade collectively known as spermatophyta. Spermatophyta literally meaning seed plant. There's a clade within seed plants called acrogymnospermae.
Fun words.
Yep, I'm doing my best here. And within that clade is the Pinopsida class.
Okay.
So the Pinopsida class is where we get conifers. That's where we get our pine trees and all the conifer subspecies of both trees and shrubs. The other main type of seed plant, other than the clade that includes
the conifers,
are angiosperms.
Now that sounds more familiar to me.
Angiosperms are specifically flowering plants.
Right, because the fruits are the result, like they come after the flowering stage.
Right.
Of these kinds of trees and plants, right?
Right.
Yeah.
Angiosperm literally means, again, derived from Greek, seed enclosed within fruit.
Okay.
Right? It's container or vessel for angio, and then sperm, seed.
Right.
Container of seed. There are plenty of fruit trees and fruit plants that can or do naturally reproduce via cloning. And technically, anytime you take a cutting of a plant to grow a new sprout, you're also intentionally cloning that plant.
Oh. So at the end of the day, then, cloning is a lot more common in plants, trees, agriculture, both at home and large scale, fruits, all of that. It's a lot more common than we think it is.
Yes.
Cool.
And to your original question, which at this point,
I don't even remember how I asked it, so good luck.
Good. I think there is probably a bias towards not thinking of cloning as a natural reproductive method for tons of plants, just because we're so used to thinking of fruits and flowers as, you get the cross-pollination.
Right.
And
bees.
And bees.
Our favorite Cards Against Humanity card.
Oh, yes.
Bees.
Bees? And that cross-pollination then being the means through which sexual reproduction happens for most of these plants, right? And cross-pollination is used for conifers, but because they have pine cones and not necessarily fruit, the delineation, as far as I'm aware, is whether or not a plant is flowering or, genetically speaking, is derived from a flowering plant ancestor that all are descended from that split off from pine trees and other conifers. So conifers and their whole class, their whole clade.
Needles and pine cones and ferns and
They split off from other green plants before flowering plants really
became a thing.
And a huge number of the plants that we see and think about today are flowering plants. Quaking aspen it's an angiosperm, and yet a huge chunk of this episode was spent talking about this deciduous tree, which
also clones.
It's an angiosperm, a flowering plant, and it clones itself. So usually when we think of fruit trees, a lot of times what people lean towards are agriculturally fruit that we can eat.
Right.
Which isn't necessarily
the definition.
Right. It's weird, the delineations that we make culturally and socially different from genetic, biological differences between these plants.
Right.
Now, I also want to take this opportunity to say, I know we have a tendency to think of conifers, pine trees, as being evergreen, right? That's another common nickname for them.
Sure.
Technically, not all conifers are evergreen.
No, the white pine in my front yard is proof of that.
Okay, but I do mean I do mean that the difference between deciduous trees and conifers, deciduous trees being trees that do cyclically shed their leaves.
Yeah, so like your maples and oaks and...
Right.
Yeah.
Not all conifers are evergreen. Some conifers are deciduous. But we think of conifers and deciduous trees as usually two separate categories.
Right.
Where technically the delineation, because that's just a trait that isn't necessarily based in genealogy.
Okay.
It probably should be thought of more as deciduous versus evergreen. Because there are plenty of conifers that have needles that are deciduous, like the larch.
Okay.
The larch is a fairly dominant species in boreal forests in Canada and Russia. And in autumn, their needles do turn yellow. And they do shed a decent number of them and grow new ones.
Right.
But they are still conifers. They're just deciduous because they do shed their needles cyclically.
Right. So within deciduous and evergreen.
Oh, I see. Within those
there
two.
There should be both conifer and some name for more leafy based versus needle based.
Right. Which is why
descriptors.
Which is why I tried to make the distinction before of flowering plants, right? Those angiosperms. And in fact, this is going to be a weird pull. I found a book from 1999 on specifically Swedish plant geography.
Okay.
That mentions the herb Cardamine bulbifera, also known as coral root, relies almost entirely on cloning itself for reproduction.
Interesting.
That its seeds, it can very rarely actually reproduce sexually.
Not
that it doesn't happen, but it's rare.
Right.
And there are plenty of other flowers that clone themselves at least fairly often. I know yellow archangel, a not uncommon garden flower, is now considered an invasive weed in certain areas of Minnesota because it has a tendency to clone itself and you think you've gotten rid of it and some of the roots are still left. It'll come back.
Right.
Right. It's not, I think, a hugely widespread problem, but it is a European plant that is now escaped from gardens into certain areas of Minnesota.
That's interesting.
Yes, I think wisteria vines also commonly reproduce asexually via cloning.
Right. And so it turns out that between deciduous, coniferous, evergreen, our cultural sense of fruiting trees, all in all, how those different forms of plants reproduce is not there's not a divide between them as much as we would think. In each category, there are ones that clone, there are ones that do sexual reproduction, there are ones that are capable of doing both depending on the circumstances. Like, it's not like all fruiting trees must reproduce sexually. All conifers often, they're capable of both, but they more often sprout. Like it depends. And
right.
Yeah.
Yeah,
there's a lot more commonality actually than difference in that.
Right. It's a shared trait that isn't necessarily controlled for, at least not on that large scale.
Right.
Right. Like, again, there are some
specific species or whatever, different circumstance, right?
Specific species more trend towards one or the other.
Right.
But it's hard to just say, yeah, all conifers tend to do this or all fruiting trees tend to do that because, yeah, it depends.
Right. So then I guess my last question really is Pando. Can we go visit Pando?
We can actually.
Okay.
Yes.
Because like you said, there's a lot of conservation efforts and stuff and science going on, but sometimes that means that areas aren't open to the public. So are tourists able?
Yes, actually.
Amazing.
So as far as I understand, there are likely sections of Pando that are closed off. Mm-hmm. But at the very least, there are some hiking trails in Fish Lake National Forest that do go through the eastern edge of Pando.
Okay.
So specifically, the Fish Lake Loop hiking trail does go through Pando.
Cool.
And alongside and through that hiking trail is Dr. Creek Campground, which allows you to camp in Pando.
Oh, cool.
Again, just in that little eastern
portion of it.
Tip, basically, of Pando. But Pando also straddles State Route 25.
Huh.
So you can just drive down this road and pass through Pando, basically.
That's cool.
Yes.
That's really cool. We'll also tell you if you decide to go visit Fish Lake and Pando and hike or camp or whatever, please be respectful and responsible.
Yes.
Hikers and visitors and tourists to the area, especially with, really anywhere in nature, but especially with something like Pando that is so rare and so old and in need of conservation. Please just always be respectful when you're out. No trash, no littering, no, take out what you bring in.
Yes.
Our favorite mantra from the Boundary Waters.
Oh, yes. The classic, anytime you're visiting any natural area, take only photos, leave only footprints.
Right.
Yes.
And even
be
then,
respectful.
Probably don't go off the trail.
Oh, no. In most cases.
Do not go off the trail.
If there is a trail, try not to go off it because it is very, very easy for only a few sets of footprints to permanently damage the undergrowth.
Yeah. So go visit Pando and support the conservation efforts at Fish Lake and enjoy
respectful.
Be respectful.
Yes. Yeah.
Because it looks beautiful. The photos of it are gorgeous. I think aspens are really, really pretty trees in general, too. Mm-hmm. And, a lot of people talk about, I want to go see the redwoods one day. I want to go see the sequoias. And, amazing. So do I.
Yes.
But there are these other really cool natural phenomenons and trees and cloning structures and whatever in nature that are accessible and far less touristy, if we're being honest. But really cool. And I think awesome places to go visit and, convene with nature and all of that.
So I would love to go visit Pando someday.
Yeah.
If nothing else, just to say that I've been there because Pando's so cool.
It is.
Just such a fascinating organism. Mm-hmm. Anywho, if that's all we've got for today.
I think it is.
Okay, then let's wrap it up.
That's a wrap on episode 4, Megaflora. If you'd like to delve further into this topic, our research sources and related images are posted on our website, hyperfixation-investigations.com. Again, that's hyperfixation-investigations.com under the episodes tab. Thanks so much for listening.
Follow us on Instagram or Facebook for updates and check out our Patreon to support us directly. Join our Discord community and receive other special perks.
See you next week, and remember, what's a little info dumping between friends?